Welcome to The Explainer. Today, we're exploring exactly how ChatGPT understands your questions. We're going to shrink down and travel right inside the machine to uncover how AI actually processes our words. Basically, we're popping the hood on systems like ChatGPT to see exactly how they take our messy human language and turn it into those calculated, highly accurate responses we've all gotten so used to. Okay, let's dive right into this. We all know the standard routine, right? We type a prompt, hit send, and boom, almost magically, we get an answer. But what is the actual, mechanical, step-by-step journey of that prompt? How does a computer program make sense of a complex human question? Today, we're going to trace that exact journey from the very millisecond your finger leaves the return key. Whether we're digging around for specific information, asking for some quick coding help, or just brainstorming ideas, millions of us rely on ChatGPT every single day. Yet, for most people, the engine underneath remains this giant black box. We see the output, sure, but the internal gears turning to produce that output, those are completely hidden from us. To really understand how this works, we first have to separate the interface from the engine. People use ChatGPT and GPT-4 interchangeably all the time, but actually, scratch that. They're completely different things. ChatGPT is the functional system you interact with. It's the chat window, the web access, the safety filters. But that whole system is built on top of a foundational model, like GPT-4 or GPT-5. The model is the actual brain doing the heavy lifting, trained on just mountains of textual data to predict the very next word. Now, when you feed that model a prompt, it triggers a process called inference. This is the live, active phase where the AI generates an output based on your specific input. Think of it like taking a student who's studied for years, and now they're applying everything they've learned directly to the test question you just handed them. So how does inference actually happen? Well, inside the neural network, deep learning works by passing your prompt through layers and layers of interconnected information processing nodes. We casually call these nodes neurons because they're loosely inspired by our own biological brains. As your words flow from one layer to the next, the model progressively transforms your text into abstract, mathematical representations. It's not actually reading English. It's crunching numbers and analyzing learned features that it automatically discovered in the data. And honestly, this is a massive leap from early AI. In the old days, we relied on symbolic or rule-based AI, which meant humans had to hand-program rigid rules for every possible scenario. It was incredibly limiting, but modern models use a specific neural network architecture known as the transformer. This architecture was an absolute game changer, allowing models to process language in a way that's incredibly fluid and dynamic. At the absolute core of this transformer architecture is something called the attention mechanism. Think about how you naturally read a long, complex sentence. Your brain automatically zeroes in on the most crucial words to grasp the meaning, right? The AI does exactly this. It acts like a digital highlighter, calculating precisely which words in your prompt are most relevant to each other so it can understand the true context of your request. So to make sense of your prompt, the AI essentially leans on a two-part system. First is its pre-training memory. It's been exposed to billions, maybe trillions of examples of text, pictures, and audio, grinding away for months on specialized computer chips. It combines this massive foundation of memory with its context window, which is the active workspace where it's reading the actual tokens or words you just submitted. But that active memory definitely has limits. We hear a lot of hype about massive context windows, but recent research from the long ICL bench dataset reveals a really fascinating bottleneck. The data shows that while models can process up to 20,000 tokens beautifully, their ability to actually comprehend and reason over the entire input just falls off a cliff when you push them to extreme lengths. It's kind of like skimming a massive novel the night before your book report is due. You're just reading small snippets instead of grasping the whole story. Section 2. Reading between the lines. How AI reasons. Let's move to the absolute cutting edge here and see how this all builds into modern reasoning models. Because we aren't just dealing with systems that predict the next word anymore. Instead of just blurting out the first statistical guess based on patterns, these new reasoning systems generate hidden intermediate steps. It's called a chain of thought. The model literally lays out calculations, subgoals, and logical steps internally. It's evaluating multiple answers, comparing them, and actively verifying its own logic before giving you a final answer. And we can actually map this internal logic in action. When researchers looked at an attribution graph for a model called Claude Haiku 3.5, they asked it for the capital of the state containing Dallas. They could mechanically trace the model's steps. It didn't just blindly guess Austin. Deep inside its neural layers, it stepped from Dallas, recognized the state was Texas, and then successfully retrieved Austin. So, the absolutely crucial takeaway here is that this isn't magic. It's not some parlor trick. We can trace these computational strategies that are normally totally invisible to us as users. These models perform genuine multi-step reasoning internally, forming clinical, logical bridges between concepts, much like a human does when solving a puzzle. And this internal logic leads to a wild capability known as inductive out-of-context reasoning, or OOCR. Check this out. In a recent experiment, researchers gave an AI raw distance data about a total mystery location, just calling it City 5037. It was just told how far the city was from other global cities. Well, using just those distances, the model internally inferred that City 5037 was Paris. Because it made that connection, it flawlessly answered follow-up questions about French baguettes and the Eiffel Tower without ever being explicitly told it was talking about Paris. The model is literally reading between the lines. It's inferring hidden, latent information by applying scattered clues to solve entirely new tasks. It's not just memorizing facts anymore. It's actively piecing together a worldview from fragmented data. Now, why should we care about this? Well, it has massive implications for AI safety. If an AI can play detective and piece together implicit clues to figure out a city's identity, it means simply deleting dangerous knowledge from its training data might not be enough. If the explicit information is censored, but the implicit clues are still hanging around, the AI's internal mechanisms could just reconstruct the dangerous information on its own, completely bypassing our simple text filters. But hey, let's keep things in perspective. Generative AI is brilliant at finding these statistical correlations and mimicking logic through a chain of thought, but it still operates very differently than a human mind. It often lacks true, grounded, contextual understanding. That's actually what researchers are chasing next with technologies like neurosymbolic AI, a whole new field aiming to combine this insane pattern-matching power with genuine, human-like reasoning. Which leaves us with this final, provocative thought. As we look at these hidden layers of attention, these interconnected nodes, and these complex chains of reasoning, as they grow more and more sophisticated every single day, are we witnessing the dawn of true machine understanding? Or are we simply interacting with the most sophisticated mathematical illusion ever built? Definitely something to think about the next time you hit send.